Here we are with Math 1 functions practice. So these first ones we're going to circle all the functions and write the domain and range. Okay. Now remember, when we're dealing with something that's a function, there are three rules. Okay. So let's go here. So in order to be a function, the first thing you need to worry about is, are there two groups? Okay. And for those two groups, we usually call the x or the y the input or the output, the domain, and the range. Okay, we also do dependent and independent variables as well. So this would be independent, and this would be dependent. Okay, that's kind of the way how we think about them. Okay. Now that's the first rule. The second rule is that we have a pattern. And in Math 1, our patterns we typically think about as linear patterns, or arithmetic, and exponential, or geometric patterns. Okay, there are other patterns out there, but that's kind of the main ones that we worry about. Now, these two pieces we don't really worry about as much when we're asked if something is a function. Okay, we look more at the third rule. Okay, and the third rule is probably the most difficult one to understand. Okay, and that one we call one-to-one. Okay, now the way we think about one-to-one is that for every input or every x or the domain, it can only have one y. Okay, only one output. A good way to think about it is kind of using these diagrams like this. So if we have some numbers here, okay, so like 1, 2, 3, okay. So as long as each of these numbers, these inputs here, only go to one output, so in other words, if I put a 2 in, I know exactly what I'm getting out of it. I'm getting a 4. Okay, that's what it means to be one-to-one. That's what a function is. Now, if I have some other numbers, maybe like this is what it would look like to not be a function. Okay, see how this input now can go to either 1 or 2. Okay, one-to-one means that for every x value, there's only one other y value, one other output that the input goes to. It can't go to more than one. That's not a function. So that's the main thing we're looking at here when we look at these. So we look at all the inputs when we're given points. See if we have any that are the same. 9, no other 9s. 0, there's another 0. Okay, so that's a red flag right there. So then my 0, what does it give me? If I give you 0, it gives me back a 4. If I give you 0, it gives me back a negative 3. Okay, in other words, that's given us this. That 0 is giving us two different options. That is not what we want to see. So this one is not a function. Okay? With a table, we look at the same idea. Okay, 0, 1, 1, 6. Okay, the 1 goes to negative 6 and to negative 2. Not a function. The other table, we have two 3s. So we look at the inputs. If we have two 3s there, then looking at their outputs, a 4 and a negative 2, that's not a function. Okay. Look at this point. 1, 2, 3, 4, 5, 6, 7, 8. There's no repeated inputs, so we're good. We don't have any, that's a function. Okay, the way you see it on graphs. Look at our x value, so say an x value of 2, does it give me two possibilities for y? It does, okay. Now on graphs there's a great way we check it. It's called the vertical line test. You basically take a vertical line and you run it across and see if the graph touches more than once. So if I've got some vertical lines here, you should see they're all touching more than once, right? Up here and down here, that's not a function. Whereas if we look at this graph down here, if I made vertical lines all across it, notice it's only ever touching the graph once. So we don't have any issues with that in terms of not being a function. So 1 and this points and this graph are both functions. So now it wants us to do the domain and the range. Now the domain is all the x values. So we do fancy brackets like that. And then what are my x values? 1, 2, 3, 4, 5, 6, 7, and 8. So I write those all down. I could go 1 to 8, but because I don't know if I have any of the numbers in between those, the decimals or fractions, it would be better off if I just wrote my numbers. And the range is all the x values, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's the domain and range of that one. Alright, now for my graph, the domain is all the possible x values. So we think, how far left do I go? Here's the furthest left I go, here's the furthest right. My domain will encompass all those numbers in between. Okay, so that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the furthest left I go is negative 11. The furthest right I go looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So my domain on this one would be from negative 11 to 9. Now my range is going to be the y value. So how far down do I go? The lowest my graph goes is right here, which would be at, looks like negative 7. The highest is up here at positive 4. So from negative 7 to positive 4 is how far my range goes. Alright, so there's that first part. Now for the rest of the problems, we're simply evaluating using that function notation. Okay, so one more thing to add, function notation. Okay, function notation has a few parts to it. We'll use this as an example. Okay, the first part is right here, usually on the left side. Okay, this is what it really gives it its function notation. You've got the name of the function. We call it f in this case. Could I do g of x? Yeah. R of x, h of x, t of x. Yeah, if I'm doing multiple functions, I can do all of those to name my function something different. So that f is there just to tell us it's a function and that it's a certain function. Okay, so it's just the name. That's all there is to it on that one. Okay, nothing more, nothing less. Now, in parentheses, we have our input. Okay, we also see that input somewhere in our pattern. Okay, same variable. So if I change this to f of n, it would be 2n plus 1. Or f of t would be 2t plus 1. Okay, so that just represents our variable and our input. Okay, now this represents the pattern. In this case, we're taking our input, timesing it by 2, and adding 1. Okay, that's the pattern we have. And f of x altogether, it represents our output. Okay, so if I'm making a table, it's like I have x and f of x. F of x is kind of in the place of the y. My input and my output. Okay, so when we're solving or evaluating, we don't deal with that at all. Okay, it's just another way to write it and just using that information. Okay, so when we look at the problems, it's going to ask us to evaluate a function based off of a number. So we say h of x equals 2 to the x plus 2. Then they say find out when h is 2. So in other words, if I were making a table, when my input is 2, what's my output? So to do that, you simply rewrite h of x as h of 2 equals, then anywhere there's that same variable, you replace it with your new number. So it would be 2 to the second power plus 2. Well, remember, exponents are multiplication, so 2 squared is 2 times 2, then plus 2. 2 times 2 is 4, plus 2 gives us 6. Now, you don't do anything with this h of 2. Okay, you don't try to divide by h, you don't try to divide by 2, times by 2, anything. That just goes down and goes h of 2 equals 6. Okay. So what that h of 2 means when my input is 2, my output is 6. Okay, so we put 6 here. Okay, if I were to graph that, that's like x, that's like h of x. Takes in place of that y. Okay, so that's what we're dealing with here. So, but all it wants us to do is to get to that point. Okay, and then we're done. So for 3, same idea. H of n equals 2 times 4 to the 2n plus 1. Find h of 1. So I write my function again. H of 1 equals, okay, replace all my n's with 1. So 2 times 4 to the 2 times 1 plus 1. So now order of operations, I deal with what's up here first. So 2 times 4 to the 2 times 1 is 2 plus 1 is 3 is 4 cubed. 4 cubed is 4 times 4 times 4. 4 times 4 is 16. Multiply by 4 one more time, and that's 64. So 2 times 64 is 128. So h of 1 equals 128. And that's how you write your answer. Alright, and so let's just work through those ones and go from there. So p of x equals x minus 5, p of negative 8. So p of negative 8 equals negative 8 minus 5. Negative 8 minus 5 is negative 13. So p of negative 8 equals negative 13. G of a equals 2a plus 4. Find g of 0. So g of 0 equals 2 times 0 plus 4. 2 times 0 is 0, plus 4 is 4. So g of 0 equals 4. And there's my answer. Once again, we don't do anything with that g of 0. Okay, that represents our output when we have the input of 0. That's what we're looking at here. Okay, so that's what we're dealing with. Alright, so second page, we've just got a few problems. Let's just knock them out. Alright, so replace the a with negative 1 in the whole thing. And then we solve that part first. 2 times negative 1 is negative 2. 2 to the negative 2 plus 3. Now, with negative exponents, I didn't realize I had any in here, so I apologize for that, but what it does is it makes it a fraction. So 2 to the negative 2 is really 1 over 2 squared, which would be 1 over 4, plus 3 would be 3 1/4. Okay, so p of negative 1 would equal 3 1/4. Okay, and then 7, h of n, so it becomes h of negative 8 equals 2 times negative 8. Replace all the n's, all the inputs with our number. 2 times negative 8, negative 16 plus 2 is negative 14. So h of negative 8 equals negative 14. Okay, number 8, h of t, but we're changing it with our negative 3. 4 times negative 3 plus 3, that's negative 12 plus 3 gives us negative 9. So h of negative 3 equals negative 9. F of x equals 3x minus 5. Find f of 5. So f of 5 replaces the x. So everywhere there's an x, I replace it with 5. So we get 3 times 5 is 15, minus 5 is 10. So f of 5 equals 10. Okay, number 10, f of a equals 2a plus 3. Find f of negative 3. So f of negative 3 equals 2 times negative 3 plus 3. That gives us negative 6 plus 3, which is negative 3. So f of negative 3 equals negative 3. And then w of x equals 3 times 5 to the x. Put in 0. Now anything to the 0 power is 1, so 5 to the 0 is 1 times 3 is 3. So w of 0 equals 3. Okay, then scoot on down. Okay, f of x equals negative 1.5 times 3 to the x. Find f of 0. So f of 0 equals negative 1.5 times 3 to the 0. 3 to the 0 is 1, so negative 1.5 times 1, negative 1.5. So f of 0 equals negative 1.5. G of x, so g of 0.7 equals 3.6 times 0.7 plus 1.4. Then using a calculator, I can just multiply that out. So 3.6 times 0.7 is 2.52 plus 1.4 gives us 3.92. So g of 0.7 equals 3.92. G of n, they want 0, so g of 0 equals 0.2 times 2 to the 0. Okay, 2 to the 0 is 1, 0.2 times 1 is 0.2, so g to the 0 equals 0.2. H of n, h of 6.3 equals 0.8 times 6.3 minus 0.6. So 0.8 times 6.3, 5.04 minus 0.6 gives us 4.44. So h of 6.3 equals 4.44. Okay, then k of t, so k of negative 1/4, so it doesn't matter if it's decimal or fraction, we still treat it the same way. Now, remember when we multiply fractions, make that a fraction. 2 times negative 1 is negative 2. 1 times 4 is 4, plus 1. Negative 2 over 4 is negative 1/2. Okay. Plus 1. Well, that's like 1 minus 1/2, which would give us 1/2. So k of negative 1/4 equals 1/2. Alright, now looking at number 17. Okay, h of 1 equals 1/2 times 2 to the 3 times 1 plus 4. So 3 times 1 is 4. 3 plus 1. Apparently I'm having issues on this last one, aren't I? Plus 1 would be 4. So that would be to the 4th, right? I'm just going to erase that so I don't rewrite the whole thing. Then 2 to the 4th, that's like 2 times 2 times 2 times 2. So that's 4, 8, and then 16. So 1/2, negative 1/2 times 16. Well, that's like 16 divided by negative 2, so it would be a negative 8. So h of 1 equals negative 8. So there we go. There's all those problems. That's all we do when we're dealing with those functions.